So we're going to finish off our introduction to probability with this three-coin experiment and a matching problem where you try to match your experience to probability. So here we go. We're going to think about tossing 3 coins. We're going to set x equal to the number of heads. What we think about doing is the same as we did with the dice. There's 3 different things that happen, and for each of them should be equally likely to be the two kinds of things that can happen here, heads or tails. So we want to make a list of all the possibilities of the 3 things that can happen in order that are heads and tails. Now it turns out there's 8 of them. There's different ways to think about that. One way is to organize it like this. Make a tree diagram of the first toss, and then the second toss, and then the third toss like this. And then make sure you used up all the possibilities for the first toss. It's either heads or tails, and the second toss heads or tails, and the third toss has to be heads or tails. And then you see here, the ends of these branches represent possible sequences of heads and tails. And we notice that there's 8 of them because it doubles each time we go down the tree. So it's supposed to be 8. And then I might have imitated that. Well, let's see if I did. So heads, 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 that's this one. Heads, heads, tails, that's that one. And then heads, tails, it goes here. So in here, whenever we can go. Now we go here, wherever we can go. Heads, tails, heads, and heads, tails, that's these 2, yeah. And then you have to start with tails. I've used up all the ways to start with heads, and I start with tails. Tails, heads, heads, tails, heads, tails, 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 heads, tails, tails, tails. So by accident, since I actually didn't use the tree diagram to help me, but it would have helped to list all the possible outcomes. And they're all equally likely because the coin tossing is supposed to be equally likely heads or tails. So there's no particular pattern that should be more likely than another. So since there's 8 of them, each of these 8 possible ways of tossing 3 coins should have probability 1/8. And then we can figure out, here's the number of heads in the tosses. So if we can get 1 heads 3 ways, that's kind of like getting 11 2 ways. You're going to take the 1/8 and add it up 3 times to get the 1. So you're going to get 3/8. There's only one way to get all tails. That gives you 0 heads. So that happens 1/8 of the time. There's only one way to get 3 heads. That gives you 3 heads. That's 3 heads, 1/8. And then the one we're missing was 2 heads. There's 3 ways to get 2 heads. So 3 times 1/8 looks like that. Now we can do some other kinds of counting to get these things to happen. I'm going to probably make some space on here and say, okay, wait a second. So if we're not doing number of heads, wait, but this thing, well, maybe we can do it. I'm going to take this out. But that might have helped me. At least 1 heads. So we just go down here, at least 1 heads. 7/8. Of course, you could think at least 1 heads. The only other thing left over is no heads. And so if there's 1/8 here, there has to be 7/8 there. Okay, do that. Since the total would be 1. No more than 2. 2 or less. 2 or less. 7/8. No more than 2. More than 1. Okay. More than 1. More than 1. More than, so 2 or 3. More than 1. 1/2. 4/8. At most 1. At most 1. So that's 1 or less. At most 1. At most 1. No, no, no. Yes. 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 Also 1/2. More than 2 heads is only 3 heads. There's one of those, 1/8. Okay. And then some more thinking required. I better make space because I don't want to get confused here. Okay. No more than 2. So 2 or less. No more than 2. Sorry, no more than 2. So 2 or less. all of these, right? No more than 2. Looks like 7/8. Oh, we had it already. Did I do it twice? Ah, I did it twice. Forget that. Well, we'll write it again just because. At least 2 heads. We don't have at least 2. At least 2 is 2 or more. That's 3 or 2. 2 or more. At least 2. No more than 2. Here's a 1/2. They're 1/2. No more than 1 is at least 2. Another way to say it. So it's going to be 1/2. At most 2 is no more than 2. So it ought to be 7/8. Okay, so there we go. Did them all. So that was our first game. And so we could actually have played that game with the numbers here if you knew how those numbers worked out. So here's the number of heads. 3, 2, 2, 1, 2, 1, 1, 0. Or we could probably have answered that question looking at the probability table. Let's pick 1. No more than 2 heads. We could look at the table and go no more than 2 heads would be 0, 1, or 2 as a possible number of heads. And then we could add up these probabilities to get 7/8. Or we could look at these and not actually have to count them. Go no more than 2. That's everything except 3. It's all of these. So that's, did I get it wrong? No more than 2. It can't be 3. So all of these and all of those, same thing. That's 7/8. So we did that. This game of playing equally likely, letting equally likely enter into the scheme of things and allowing it to decide what probabilities are works pretty well. It works for most games of chance, roulette, poker, pick a thing. But sometimes you have to look at sequences of outcomes like this that are equally likely when really you're only looking for the total. So things can get more complicated than you might think in terms of analyzing the experiment. Here we go. It's a matching problem. Experience, you see almost always, almost never, rarely, frequently, more often than not. What kind of probabilities do these come across as? And this, you more or less can go through them in a process of elimination. So I'm going to do that. The ones I know about are always has probability 1 and never has probability 0. So if it happens always and I count how many times it happens divided by the number of experiments, you get 1. So these are gone. All right. And then almost always and almost never. Almost always should be close to 1. So I'm going to put 0.99 there. And almost never, it should be close to 0. I'll put 0.01 there. I'm hoping this works. And then we've got these other numbers. So the ones that seem a little more lackadaisical, like maybe, maybe not, I don't really know. Those might be harder to pick up. Rarely and frequently seem like they're sort of the opposite of each other. Frequently is often. Often to be a high probability. I'll put 0.95 there. And rarely ought to be a small number, but we don't have any small numbers left. I'll take this one, 0.05. Okay. And then we have these middle of the road probabilities, 0.6 and 0.2. More often than not, sounds like 0.6, because more than 1/2. And every once in a while, sounds like 0.2. 0.2 would be like 1 in 5 chance. That sounds like it once in a while. It's not quite rare, every 1 in 5 chance. This is a 1 in 20 chance. So that's my take on assigning numbers to experience. It can help you when you look at homework questions and they ask you, how would you describe these kinds of probabilities? What kinds of words would you use? These kinds of words match those kinds of numbers. Cross these off. So that completes section 5.1. And we're going on to 5.2, and we'll see you in a while.